The answer is C. Pet dinosaur. I'm a pet dinosaur. I like it. I like it. I know, we do, but after I get grades in, which means tomorrow you can ask me.
Did you already put in extra credit for that, or is that like later? It was like something about finding weird ways to get weird last year. Because like at each, and we're like weird. Yes, it's kind of self-sufficient.
This is the same reason, right? It's the same reason. Thank you. A and B are both not legal because of the same exact reason, because there's no point at, well, 4-0 doesn't work either because that's not an absolute min, right? Because the function goes lower in this region. And then letter A, there's a hole at that point. And then letter D, no extrema. I see a max, don't you? All right, number 75. Ready? Someone new. This one might require a little bit more work. Well, they both required work, just this one might require writing. Any marks, get set, and go. Just critical numbers. Just critical numbers. If I were you, I would do the cool green pen trick. I would do the cool green pen trick. Factor, don't distribute. Factor, don't distribute. Don't you dare start distributing. That would be really unwise. Factor. No one's submitted yet. No. Yes. But can you show why? But can you show why?
Oh wait,
I would pull an x out and then combine. You got scared of that and you stopped. Don't get scared of that. Simplify. Don't get scared.
see, that's what I was gonna do.
This is the product room.
Dun dun dun.
Where's that?
Anybody else? Yes. Do you know why? Good. The key was factoring. The key was factoring. All right, one more minute to see if you can get there. If not, it's okay. But I need you to see how to do it. One more minute to see if you can get there. All right, I'm going to start playing. Some of you guys have gotten there. I think 2 groups are still working. 1 or 2. What did I have to do first? Yeah, product rule. And then what did I mean by the green trick? And maybe some of you heard that, maybe some of you didn't. What did I mean? Yeah, you can take stuff out, right? It was key, because without taking stuff out, you wouldn't find all 3. So then we have the x, and we have 3x minus 1. That made everything so much better inside. Because now I just have a 2 with a 3x minus 1. I have a 9x, and that's it, right? I simplify that, and I end up with an x times 1 quantity squared times 6x plus 9 is 15x minus 2. All I have to do for critical numbers, top and bottom equal to 0. No, I only have a top. Okay. Just find the zeros. There are no D and E's. And that's going to occur at x equals 0 from the first factor. X equals 0, 3x minus 1 equals 0. X equals 1/3 from the second factor. And x equals 2/15 from the third factor. Dun, 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 dun. It's D. A couple more seconds to get down what you need, but then grab out your colored pen and let's go grade those evens. Grab out a colored pen and let's go grade those evens. Huh? Oh. From section 3.1, starting with number 4, I think, right? All right, let's have you guys start grading. Number 4 and number 6. What? Why was it so crazy? Hold on. Didn't the first pictures or the first functions have graphs? Oh, couldn't you have just looked at it and seen if it was a smooth turn or a sharp turn? Oh, no, you could have solved by hand. And if you solved by hand and looked at the relative that they were talking about, the min or max, the derivative was 0 on number 4, but you could have looked at the graph and been like, that's a smooth turn, 0. But the math does back it up. On the second one, what? They said you would have had to use the limit definition of the derivative. We actually memorized the derivative rule for absolute value. So you could have just taken the derivative of absolute value of u is absolute value of u over u prime. Long story short, if you tried to plug in, coming from both sides doesn't agree. The limit does not exist. But another way of looking at it is it's a sharp point. Of course the limit does not exist. Sharp point. Of course the limit does not exist. Number 10, now we got into... What's going on number 10? Did they give you a function or a graph? Oh, that's why. Okay, so looking at the two different critical numbers, the two different places where the derivative was 0 or dne. X equals 2 was neither. It was nothing. But x equals 5 was an absolute max and technically a relative also, but absolute is the best descriptor. Number 12, you would have had to take the derivative, factor, set the factors equal to 0. Don't worry about dne's because there is no denominator. Critical numbers at 0 and plus or minus 2. Let me give you a second on 36. It's a trig one. Derivative of secant is secant tangent. That's directly out of our forever cards. But once you have secant tangent, once you have secant tangent, you have to think about both of those guys because they're being multiplied. They're both factors. So critical numbers set the factors equal to 0. Critical numbers set the factors equal to 0. So, can secant equal 0? What do you guys think? Can 1 over cosine ever be 0? They didn't give you a graph on this one, right? Okay. I mean, you could have technically if you wanted to. Couldn't you actually have gotten secant's graph and said, like, hey, where's his mins and maxes? Yeah, you could have cheated and done that. That's a good cheat. Because it's a basic graph, isn't it? So you could have said secant's going to have critical numbers and at, let's see, that's going to be 3 pi over 2. And at, well, wait a minute, hold on. Didn't they give us, so we're only going between negative pi over 6 and pi over 3. Pi over 2, pi over 3 would be like over here. So the only one we have is at 0. The other way of looking at it is you could have set secant equal to 0 and tangent equal to 0. Secant equals 0. I don't know. 1 over cosine equals 0. I don't know. 1 equals 0. Wait, if I multiply cosine, that can never happen, right? Secant never hits 0. So this is impossible. I don't need to worry about that factor. Well, who's the other guy? Tangent. Does tangent ever equal 0? Does sine over cosine ever equal 0? Multiply up the cosine. That happens when sine equals 0. Cool, kids. 0 and pi. So at 0, within the interval, the only time is 0. So then you go ahead and set up your endpoint number 1, critical number, endpoint number 2. And when you plug in this at pi over 3, this guy ends up being the lowest value because that guy is at some weird decimal at 1 or of 1 at 0. Does that kind of make sense? What do we have to study? Starts with the U and ends with a knit circle. Yeah, 48 and 62. Do you guys have a graph on 48? Okay. And then 62, you were just labeling. I think we had one super similar to that in our notes, right? I think we just labeled everybody. Don't worry, I'm coming back. Okay. Those are our last two. Let me give you a second on those. But those of you guys that are ready for questions, I'm going to freeze the screen and try to go find your questions. What's the first question we have on homework? Or do we have any? Yeah. 67. Anything before 67? 36. Anything before 36? 15. Anything before 15? 29. Okay, so let's go 15, 29. We might not get all of these today because it is chapel day, but I'll get at least a couple. And then remind me, and tomorrow we'll finish up homework questions because I still want us to get into section 3.2 today. Obviously not finishing it, but starting on it at least. Okay, I have the book open, 15, then we're going to 29, then we'll see if we can hit one more before we go into section 3.2. Number 15, Allie, help me out really quickly. Directions, critical numbers or absolute extrema? What are we doing? Okay. What am I going to say that you guys shouldn't do? Oh, I have to say the whole thing? Don't get... Why? How does that apply? Good. So what are you going to do? Pull out the squared. You're just rewriting it, what it actually means. That's what it actually means, right? Okay, so if I'm finding h prime of x, sine of x, derivative of u squared is 2u times u prime. Come on, you guys see it? Green trick, right? What next? If you're doing critical, you need to factor because you need to set equal to 0. And the best way to set equal to 0 is if I have factors equal to 0. Because then I can say, hey, when do u equal 0? And when do u equal 0? Zeros of cosine, cool. And then the negative 1/2 of sine. I'm looking only one time around the unit circle. Yeah. Oh, thanks. I only did half of it, didn't I? Gracias, chicas. Because I need to pull out another function. Oh, I have to erase all of this? It's okay. I feel your guys' struggle. You missed something, have to go back and erase it all, yeah? That's why I have had multiple calculus kids actually invest in a little baby whiteboard or just like a page protector to have at home, and they actually work it out first to make sure they get it, then put it in their paper. It's an idea. At least on harder problems. I have a college kid that still does that. She has her whiteboard at home. She's like, oh, I have it at my whiteboard, don't worry. So, okay, cool. Pulling out sine of x and 2 cosine of x minus 1. Same process applies, factors equal to 0. But yeah, my answers would have been horribly wrong. Cosine equals positive 1/2. Now, if you think units, you could think of when are the y's equal to 0 and when are the x's equal to positive 1/2. If you think sine's graph, you could say, hey, when does sine equal 0? Well, sine equals 0 at 0 and at pi and at 2 pi, because that's where it hits the x-axis. The only one in between is pi. But that's the exact same thing as if you were to think of the y's being 0, because that's negative 1, 0. And then for unit circle, it'd be over here somewhere, but 0, 1, 0. Anyway, but that's unit circle. Cosine 1/2. You could think of when will cosine go through 1/2? And maybe you'd be able to figure it out from there. It's not pi over 4, that'd be root 2 over 2. And then again in the fourth quadrant. But for most of you, probably unit circle will be of cosine equals 1/2 when x equals 1/2, which is at pi over 3 and 5 pi over 3. Those are the only that fit in between one revolution of the unit circle. The other way of writing it is sine goes down, cosine goes up. So 1, 2, 3, sine goes up. 1, 2, 3, 3, 2, 1. Cosine hits 1 at pi over 3. But that's cheater chart. If you need help on the unit circle, come talk to me. That's not for today. Number 29 was our next one, right, Patricia? That was yours? And then remind me at the beginning of class tomorrow, and we'll hit the other two that you guys had questions and any additional ones, since it'll be non-chapel schedule. any additional ones. So have those questions ready. You can also maybe get them answered in 0 period tomorrow morning. I'll be here for a little bit today, not super long. But here we go. Number 29. Help me out. Absolute extrema or critical numbers? Okay. So I know right away. Oops, it's not even an X, it's an S. Changing variables throws me off sometimes. I know right away 0 and 1. I'm looking for any critical numbers in between, right? Could you have done quotient rule, yes or no? Yes. You would have gotten bottom d top to be 0 minus top d bottom all over bottom squared. Could you have also rewritten this to make it s minus 2 to the negative 1 power? Yes. We've got negative 1 s minus 2 to the negative 2, aka squared in the denominator times u prime is just 1. Pitchfork, so the top equal to 0. The top is a number, it'll never equal 0. Well then forget that, that's impossible. So at the bottom equal to 0. A, domain says s isn't allowed to be 2 anyway. So technically if the function exists, the zeros and DNEs are critical numbers, so technically this is a domain problem. More specifically, this is a vertical asymptote. But even more specifically, is 2 between 0 and 1? Huh? Well, this is one of those where it's been cut and there's no critical number, no sharp point or smooth turn in between. So okay, fine. Just plug in 0, which is going to be negative 1/2, and plug in 1, which is going to be negative 1. This guy's lower, so he's going to be the absolute min. This guy is higher, so he's going to be the absolute. Is that cool? All right, my other 2 questions, please hold on to them. I do want to hear them, and we'll get to them first thing tomorrow, okay? Let's go ahead. And section 3.2. The nice thing is with the Google Classroom, we might do this a little bit more often in the sense of having like a packed day before us, needing to get into notes, homework questions taking long. I might spread homework questions over a few days. Number 1, it makes you guys review what we did the day before, even if you're not currently having homework on it. It makes you guys review, and it also allows us the freedom, because you're really just trying to figure things out by test day. It allows you guys the freedom to not need to tackle every single question all at once. So I think that would be a good idea. Okay, nice thing is homework number 18 is not due until Thursday, but we still need to get a start on it because there's a lot going on. Not necessarily a lot of math, but 2 new forever cards. Not necessarily a lot of math, but 2 new forever cards. Which I might actually once again make into 1, kind of like I did yesterday. What was the forever card we did yesterday, guys, as you're writing down notes? Oh, critical numbers. We do have that one. That was from Friday or Thursday. What's the other one that we did yesterday? Good. Absolute extrema, right? Absolute extrema. And in the absolute extrema card, what theorem did I give you the short, sweet version of? If a function is continuous on a closed interval, there must be an absolute max and min at critical numbers and endpoints. What theorem did I give a short, sweet? EVT, extreme value theorem. So we put 2 cards into 1 because really, you're not going to have to worry about EVT unless you're thinking about absolute extrema. We might do the same thing in section 3.2. As you guys are writing this down, there are 2 different theorems up there, Rolle's and mean value theorem. There are 2 different theorems up there, Rolle's and mean value theorem. So what you guys are writing down, it's good. It actually was discovered first. Showed around 1691. There was an actual guy, his last name was Rolls. It's probably not even pronounced Rolls, but whatever, that's okay. I think it might be Rollies. Mean value theorem. I'm going the wrong way, I apologize. Hold on. Come on, notes, what's wrong with you? Yikes. Okay. But this one came first. I want you guys to write next to this one, specific MVT. Rolle's theorem is a specific case of MVT, but the generalized version came later. I'm trying to think of like some example of science or something where like a general thing might have been discovered and then they were able to generalize it for all of a certain category of thing. I can't think of one right off the top of my head. I'm sure there are plenty though. Oh, here's an example. If you were to add, this is in math, but that's okay. I couldn't think of a science one because I'm not very good at science either. If you were to add, had to do with my high school math teachers in general. Great math teachers, great English teachers. Anyway, coming back. If you were to add an odd number and an odd number, an odd plus an odd plus an odd, what do you get? Let's take an example. 13 plus 7 is 20. Oh, that's interesting. It's an even. It was true in one case. But what if you kept on finding more and more and more cases? What's true when you add any odd? Always even. Because an odd is always one more than an even. So take that one